Picture this. The ground beneath your feet, solid as it seems, is on the move. Not just creeping along, but possibly picking up speed. Scientists are buzzing with a question that sounds like it's ripped from a sci-fi plot. Are Earth's tectonic plates, the massive slabs that shape our continents, oceans, and mountains, actually accelerating? If they are, the consequences could be staggering, reshaping everything from coastlines to climates. Welcome to the global tectonic shuffle, a mystery that's got geologists, climate scientists, and even urban planners on edge. So grab a coffee and let's dive into this restless, rumbling world beneath us. Imagine Earth as a giant jigsaw puzzle, its pieces constantly shifting, grinding, and reshaping the planet over millions of years. That's plate tectonics in a nutshell. These massive plates, some as big as continents, others smaller but no less mighty, float on a semi-molten layer of rock called the mantle. They're the reason we have towering mountains like the Himalayas, sprawling ocean trenches, and the occasional earthquake that reminds us who's really in charge. The plates move slowly, usually at the pace of your fingernails growing, about 1 to 10 centimeters per year. But slow doesn't mean insignificant. Over millions of years, this movement has shuffled continents like cards in a deck, splitting ancient supercontinents like Pangaea and pushing land masses to where they sit today. It's a dance that's been going on for billions of years, driven by heat from Earth's core and the churning of molten rock deep below. But here's the kicker. What if this dance is speeding up? What if the plates are moving faster than they used to? That's the question scientists are grappling with. And it is not just academic curiosity. It could change everything from how we predict earthquakes to how we plan cities on fault lines. So are the plates actually speeding up? The short answer is, we're not sure. But there's enough geologists have been studying plate movements for decades, using everything from ancient rock records to modern GPS technology. By looking at magnetic stripes on the ocean floor, formed as molten rock pools and locks in Earth's magnetic field, scientists can estimate how fast plates have moved over millions of years. For example, the mid-Atlantic ridge, where the Eurasian and North American plates pull apart, has been spreading at about 2.5 centimeters per year for the past 10 million years. Other plates, like the Pacific plate, can move faster, up to 10 centimeters per year in some spots. These speeds seem stable when you look at the long arc of geologic time. But stable doesn't mean unchanging. Earth's history is dotted with periods of faster or slower plate movement, often tied to massive geological events like the breakup of supercontinents or huge volcanic eruptions. Fast forward to today, and technology like GPS and satellite interferometry lets us measure plate movements with pinpoint accuracy. These tools track tiny shifts in the Earth's crust, down to millimeters. Some recent studies have raised eyebrows by suggesting that certain plates might be moving faster than expected. For instance, research on the Pacific plate suggests its speed may have ticked up slightly over the past few million years, possibly due to changes in the mantle's convection patterns, the engine that drives plate motion. Then there's the Indian plate, which famously smashed into Asia to form the Himalayas. Some geologists argue it's still speeding along faster than it should, based on historical data. Why? One theory points to the mantle beneath it, which might be hotter or less viscous, letting the plate glide more easily. Another study from 2023 hinted that the rate of seafloor spreading at certain mid-ocean ridges might be increasing, though the data is still debated. But here's the catch. Not all plates seem to be speeding up. Some, like the African plate, appear to be slowing down or staying steady. This patchwork of evidence makes the question trickier. Are we seeing a global trend or just regional quirks? If plates are moving faster, something's got to be pushing them. The most likely culprit is the mantle, that churning layer of semi-molten rock beneath the crust. Here are a few possibilities scientists are exploring. The mantle moves like a pot of simmering soup, with hot material rising and cooler material sinking. If this convection is speeding up, maybe due to changes in Earth's core heat or chemical composition, It could push plates along faster. Massive plumes of hot mantle rock can rise from deep within the Earth, potentially supercharging plate movement. Some geologists think we might be in the early stages of such an event, though evidence is sparse. Here's a wild card: climate change. As glaciers melt and sea levels rise, the weight on Earth's crust shifts. This can subtly affect plate movements, especially in places like Greenland or Antarctica. Some models suggest this glacial isostatic adjustment could nudge plates to move faster in certain regions. Could we be playing a role? Probably not directly, but some scientists speculate that large-scale mining, reservoir creation, or even groundwater extraction might tweak local stresses on the crust, potentially influencing fault lines. It's a long shot, but it's on the table. Okay, so let's say the plates are speeding up. Why should you care? Because even a small increase in plate speed could ripple through the planet in ways that hit home. Faster plate movement could mean more frequent or intense earthquakes, especially along plate boundaries like the San Andreas Fault or the Ring of Fire. If plates are grinding past each other or colliding faster, the stress buildup could trigger quakes sooner than expected. For cities like Tokyo, Los Angeles, or Istanbul, built on or near fault lines, this could mean rethinking everything from building codes to evacuation plans. Volcanoes are another concern. Plate boundaries are hotbeds for volcanic activity, and faster movement could stir up more magma or destabilize volcanic systems. Think of places like Iceland or Indonesia, already volcanic hotspots, potentially seeing more eruptions. Over millions of years, faster plate movement could redraw Earth's map. Coastal regions might face new risks as subduction zones, where one plate dives under another, become more active. Mountain ranges like the Andes or Rockies could grow faster, while low-lying areas might sink as plates shift. It's not like California's going to crash into Japan tomorrow, but over geologic time, the changes could be dramatic. Plate tectonics shapes climate in surprising ways. For example, the uplift of mountain ranges can alter weather patterns by blocking winds or creating rain shadows. Faster plate movement could accelerate these changes, potentially shifting ecosystems or agricultural zones. Ocean currents, which depend on the shape of continents and ocean basins, could also shift, affecting everything from fish stocks to global temperatures. If plates are speeding up, engineers and urban planners will need to adapt. Bridges, dams, and skyscrapers built on fault lines might face new risks. Coastal cities could see increased subsidence or flooding as plates shift. Even energy infrastructure like offshore oil rigs or wind farms could be affected if seafloor spreading changes ocean floor topography. Not everyone's convinced the plates are speeding up. Some geologists argue the evidence is too patchy, with too much variation between plates to call it a global trend. Others point out that our measurements, while precise, only cover a few decades, hardly a blip in geologic time. What looks like a speed-up could just be a temporary fluctuation or a misinterpretation of data. There's also the question of scale. Even if plates are moving a bit faster, say from 2 to 3 centimeters per year, the difference might not be enough to cause major disruptions in our lifetimes. The real impacts would unfold over thousands or millions of years, which makes it hard to get people excited or worried about it now. So, where do we go from here? Scientists are doubling down on research, using advanced tools like satellite-based radar and deep Earth imaging to track plate movements and mantle dynamics. International projects like the Plate Boundary Observatory are collecting data to see if the trends hold up. Meanwhile, computer models are simulating what faster plate movement might mean for earthquakes, volcanoes, and climate. For the rest of us, it's a reminder that Earth is anything but static. The ground we walk on, the mountains we climb, the oceans we sail, they're all part of a living, breathing planet that's constantly reshaping itself. Whether the plates are speeding up or not, the tectonic shuffle is a humbling force, one that's been at work long before us and will keep going long after. The idea of accelerating tectonic plates is both thrilling and unsettling. It's a reminder that Earth is a dynamic, ever-changing system driven by forces deep beneath our feet. While we don't have all the answers yet, the question itself, are the plates speeding up, pushes us to think bigger about our planet's future. Will we see more earthquakes, shifting coastlines, or new mountain ranges? Only time and a lot more data will tell. For now, the global tectonic shuffle is a mystery worth watching. So next time you feel the ground under you, take a moment to wonder, is it moving just a little faster today? And if it is, what does that mean for the world we call home?